Yeah, awesome. Okay, so my name is Damian. Thank you guys for coming out. I found some cool things to do with Nvidia Morpheus. So maybe you guys aren't familiar with Nvidia Morpheus, but it's a framework by Nvidia for kind of taking in data from your environment and pumping it into like this way, like having some sort of way to format it and take out some insights from it. And it's like an AI framework that Nvidia made. Without getting into too much detail, think of it as like something like a pipeline for your data. It goes in and some kind of, I guess, prediction comes out from a model. That's all it is. You can think of it as a kitchen. So I've never watched The Bear, but I've seen a lot of YouTube shorts about it. I watched a lot of clips about this show. But pretty much the framework is like it gives you all the tools, it gives you the pans and the pots and the sauce to do all your work. And it comes out some kind of dish, or in this case, a prediction. A model spits out something. It tells you, hey, this is what was happening on this day, or this is a phishing email, or some sort of deterministic like thing that comes out of the model, right? And you can think of it as like you're like the user. You ask for a dish, and comes out something that you asked for. So one cool thing you could do with NVIDIA, if you've ever used Darktrace is an NDR kind of AI-powered solution that we have at SOCs nowadays. What it does is it pulls in a bunch of IP traffic from your environment. That makes it's like you register subnets on your environment, and it pulls in a bunch of data, and it shows you like this subnet was speaking out to this domain, or this is an anomalous domain. It's not very common for this endpoint to talk to this endpoint. That's what all Darktrace does. And under the hood, you can think of it as like these endpoints, the dots on the graph, they're speaking out to each other, and those lines are like the traffic, you can imagine it. So it's speaking out to each other, and this model, what you won't hear in the video, but the model, what it's trying to do is trying to find credentials that are unencrypted. So the red line is like unencrypted credentials over the wire. So it finds that, and in this case, that endpoint that's circled turned off encryption for itself. So anything that speaks to it doesn't use encryption. So now anything that speaks to it is transferring unencrypted credentials over the wire. So that's a cool little demo of what Darktrace does and what NVIDIA Morpheus can do. Under the hood, what it's doing is it's taking all this data from your environment, it's passing it to a model we call inference, where we have a model server, like the model lives on a server, like a literal server, and you feed it data, and you ask it, hey, what is happening on this data? And the model comes back and it tells you, hey, this is what's happening on the data. So all it does is you give it something, and it pops out another, like, I guess, something that you might want to look at. So another thing you can do with NVIDIA Morpheus is something called digital fingerprinting, or UEBA. So that stands for user and entity behavior and analytics. So all that means is that we have users in our environment, right? And we kind of want to know what they're doing. Sometimes we have things called insider threats. So that's people that are inside our network, our environment, and they're acting maliciously. Maybe they're doing it on accident, or they're doing it on purpose. But we want to know when these things happen, right? So in this case, we use some sort of like AI model called a neural network. So neural networks are modeled after our brains. So how it works is that we have a model called an autoencoder. The purpose of the autoencoder is it takes in data, an input, and it compresses it super small. And at the very end, it tries to recreate that input as output. And if there's a match, then there's less loss, or like a smaller, I guess, smaller change. And if there isn't a match, that means there was an anomaly, right? The model couldn't predict the anomalous behavior that came out, right? So it compares it from what we saw in the environment to what should have happened. For example, we train it on regular baseline data, and it recreates it, and it trains over and over again, and it learns, hey, this is the baseline. And when it sees something, it can't recreate that anomalous behavior, so it shoots a spike. That's what our autoencoder does. So it tells us where the spikes are, and in this case, where there's a lot of error in the model. And if there's a lot of error, then it tells us, and it shoots an alert. And that could be in the form of like a dashboard, like how we do in our SOCs. We have dashboards that tells us this alert happened, or this something happened. So that's what digital fingerprinting is, and it helps us do it across each user. So it's something I pulled from my own research, in that we have an autoencoder or a neural network for each user. It's like each user had an AI model assigned to them, and that AI model learns what they do every day. And if there's an anomaly, then it'll pop up on our screen. That's all it does. And the way NVIDIA Morpheus allows us to do this is it's that kitchen, right? It has all the tools that enable us to do this. It has the pipeline, the data where data comes in. It has the inference model, which tells us it runs its predictions on it, right? It has the logic. It's like the brain that learns this, and it spits it back out to us, and it tells us, hey, this is anomalous. This is where the red alarms are happening. You should check this out. So here's a more, I guess, what's happening under the hood. So this is what's happening actually under, like what's happening, like what NVIDIA Morpheus is. So if you've ever used Apache Kafka before, Kafka is this data streaming pipeline that a bunch of like high performance, like I guess companies use. So think of Netflix. Netflix has a lot of streaming data coming in and out. And the way they handle that is Apache Kafka. So Kafka kind of decentralizes it. It sends it across multiple pipes and it just, passes them all evenly. So that there's no like bottlenecking, right? If we have a bottleneck and then we can't get data out and we can't get data out, then our users are not happy, right? So all Kafka does is imagine you have a bunch of logs from all your different users like we saw before. So we pull them all in and we run inference on them. Inference, like I mentioned before, is just the model making a prediction or making a determination on the data we give it. So we have the data from Kafka, we pull it in, we make a determination on it, and it comes back in the form of, I don't know, depending on if you use Elasticsearch or Kibana or Prometheus or Grafana. These are all different tools that we use as cyber security people every day. You might not use all of them, but you might have heard of one or two of them. And that's all it does, So we have, in this case, we have authentication logs. We pull them in, put them in a pipeline. We ask the model, hey, what do you think about this? Is it anomalous? Is it regular? It tells us, and it gives us, like, it puts that on our dashboard, right, for us to look at easily. So another application that NVIDIA Morpheus gives us is phishing and spear phishing detection. So like I mentioned, you can just pull anything. Like think of anything you can imagine that you have in your environment, whether it be cloud logs or, like I mentioned, Prometheus logs, Kubernetes, anything in the cloud or on-prem. So NVIDIA Morpheus has a huge use case in databases or in data centers where you have these tons of servers and you need some way to compute on this data in like a way that doesn't cause bottlenecking or cause any sort of like breakdown when it comes to like processing data. So with all that data coming in, you have to have some sort of way to crunch it really fast. And NVIDIA Morpheus uses what's called CUDA. So CUDA is another NVIDIA product, I guess, proprietary, where it enables your GPU to function as a CPU. So you might have heard of these databases using a bunch of GPUs, like people buying GPUs and RAM. Well, the reason they're doing that is because they can run computations on GPUs instead of CPUs, right? CPUs, they don't provide as much power as GPUs can. We've optimized GPUs a lot more, and there's a lot of reasons why and how we can optimize GPUs better than CPUs. But in general, just know that GPUs are really, really strong with CUDA and running computations. So you can imagine you have a bunch of cloud logs coming back to the phishing detection kind of use case. So a bunch of logs come in. You ask the model, hey, this is the email I got. Can you run a prediction on it? Can you tell me if it's anomalous? And the model, of course, is trained on emails that are across the internet, right? It has a database of emails. Some of them have been marked as phishing. Some of them have been marked as not phishing. This is what we call supervised learning. We have information that's already been labeled as malicious or non-malicious. And then we give it that, and it trains it, and it learns it. And then we give it another email that it hasn't seen before, which it could be from your own environment. And it tells us, hey, this is malicious, this is not malicious, and it gives us a score. So that's what this is doing under the hood. In this case, I want to go back to the autoencoder. So we have supervised learning and unsupervised learning, right? Supervised learning is where we have labeled data, we feed it to the model, and we tell it, hey, this is what this data is, malicious or non-malicious, and it learns, right? It learns, okay, this is an example of non-malicious, this is an example of non-malicious or malicious. In this case, we don't have that, right? We just have user behavioral data. But it comes in and it's not labeled at all. It's just data, right? It's just this person logged in at 8 a.m., this person did this at 2 p.m., stuff like that. It's not labeled, right? So the way autoencoders work is the goal isn't to give it, like to come up with a solution like a label, like malicious or non-malicious. It just tells us, hey, I couldn't reconstruct it because it's so anomalous that I couldn't predict it. That's all this is saying. Like this isn't a malicious, not malicious label. It's I couldn't reconstruct the data from what I was getting. And that's how we know, hey, we can like, this is not normal because our autoencoder couldn't recreate it well. So the last use of NVIDIA Morpheus I want to go over is what's called graph neural network fraud detection. So graph neural networks are another type of neural network. Like I mentioned, we have autoencoders, which is one kind of neural network. Graph neural networks, what they do from a top-down view, I guess, is that they have, if you imagine a graph with nodes connecting each other, you can think of each node as an asset. So one's a server, one's a user, one's another server, etc. Right? They all connect each other, right? In your environment. You can think of it as a user, I touch a machine, and that machine touches a server, and that server talks to this and that, right? There's all connections all over the place. So what a graph neural network does is it learns these connections based on how common they are to each other. So I guess you can kind of think of it as these 4 users in yellow are possible fraudsters, and they all communicate and do the same behavior. And the problem is we can't do this with normal machine learning neural networks because sometimes these changes and these actions are so subtle that you can't notice them as a single person. Like a single person might be working in a group, but if you were to look at that single person's behavior, it might come out as benign. When you get the context of multiple people working together, then you see the bigger picture and you're like, hey, this is not normal. Right? This guy's sending it to this guy's sending data to this guy, and this guy's sending data to this guy, which ends up going to this server, and they also talk to the one server. So it kind of forms a bigger picture. And the graph neural network learns that for us. So it learns these connections by talking to its neighbor nodes. And it's like, hey, I have this in common with you. That means we're part of a group. That's the point of the neural network does for us. So it learns, hey, this is what the group called, like the common group behavior is. And it comes and tells us, hey, this group of servers and asset and emails and users all kind of do this one behavior. And it's not matching up with other user behavior in our environment, right? So we have normal users, and then we have a group of users that do a common behavior that isn't normal in our environment. So that's all the use cases I have for NVIDIA Morpheus. Just to review, NVIDIA Morpheus is a framework for AI that takes data, puts it through a pipeline, it processes it, what's called pre-processing. So if you think about data, it comes in and it's not structured, right? NVIDIA Morpheus structures it for us. What's called feature engineering, where we have unstructured data, it takes it out and it says, okay, this looks like time, like a timestamp. This looks like, I don't know, a date. And it puts that into, I guess, a table. So when you write it, when you make a table, you have columns, right? Columns like name, date, time, etc. It does that for us, right? It tells us, okay, this looks like a date, so I'm going to put it in the date column, etc. So it does that pre-processing for us. And once we have the tables, we can start doing computations on them, right? Computers really like structured data. Machine learning algorithms don't work at all, like well at all with unstructured data, especially if you're doing a supervised method. Even when you do unsupervised methods, there have to be some sort of structure there, right? Computers like numbers. They're not like humans where they can understand strings. The only reason computers can understand strings is that under the hood, they're actually computed as binary, right? It's like numbers deep down. So computers like numbers. So we have to process them so that computers can organize them as numbers, right? As tables, as some sort of organization. Okay, so NVIDIA Morpheus does that pre-processing for us, and then it takes it to an inference model or the inference server. So we call there's different inference models out there that run our predictions for us. So we give it to the inference model, and it comes out with a prediction or a classification, right? Some sort of answer to our problem, and it comes back with that, and it gives us our solution. So NVIDIA Morpheus is great. There's different, like I mentioned, there's Kafka. And you could probably make your own version of NVIDIA Morpheus. You can make your own data pipeline with Kafka. You could do your own computations with other sources that aren't NVIDIA like, I guess, NVIDIA specific. But NVIDIA Morpheus is great because it puts it all in one package for you. And it comes with a bunch of models that come out of the box. So these models have all been pre-trained, and they're all free for use by NVIDIA. So there's a whole list of things you can do with these models that have been pre-trained to do exactly what I've been talking about. So you have models that do sensitive information detection, which is what we saw in the first slide with the video. It detects when credentials are being spread across the internet or the wire unencryptedly, right, with no encryption. Phishing able detection we talked about. Anomalous behavior profiling we talked about, which is the UEBA. Digital fingerprinting, also UEBA. The flexible log parsing, think of it as just like parsing logs and getting insights from that. So there's a bunch of models that NVIDIA provides for you that come out of the box. So you don't have to do any of the training yourself. Really, it couldn't make it, NVIDIA Morpheus couldn't make it easier for you to start making your own solutions. And as someone who really likes security engineering, I think this is really exciting because you don't have to do any of the hard work yourself. NVIDIA gives you all the tools for free and open source, and you can start making your own solutions with it, right? You can start making your own dog trace, for example, from scratch. And not even from scratch, NVIDIA gives you models that do it for you. Dog trace trains their own models. They have their own sequence of models that are closed source. You can't use them. But NVIDIA does it for you, right? And you could start maybe imagining in your head, hey, what if I make some sort of solution that does dark trace but better? It does dark trace, but it has a bunch of these other features to it. Maybe you could put a group of engineers together and make a solution that does dark trace but better. Or it makes a solution that's competing with what's currently available on the market. Right? And maybe you could sell that or pitch that to somebody. And you don't have to make it all from scratch. Yeah? NVIDIA Morpheus does a lot of that for you. So I think it's really exciting as someone who likes building their own stuff. I think there's a lot of potential in this. You could do your own research with it, like I'm doing right now. Maybe tackle an open problem. For example, one problem I'm tackling right now is how can we like with the autoencoder issue where we had our autoencoders learning user behavior and restructuring it and having the anomalous score go up. What happens if people get promoted, for example, in the company, and then their behavior changes? Well, our anomalous scoring thing is going to shoot that right up, right? Because they're going to have access to new things that they didn't have access to before. So our original model is going to be like, hey, this isn't normal. This is like out of the normal where they're accessing files that they didn't have, that they didn't access before. So that would shoot our model up. So how can we tell the model, hey, this changing behavior is normal, and how can we tell it that changing behavior is fine in this context? Like, how can we give the model context so that it doesn't overreact when something happens like that? You know, because changes in companies happen, right? People get promoted, people get demoted, people change departments. There's changes naturally that happen in our organizations, right? And regular autoencoders can't do that. They learn the baseline, they learn to reconstruct it, and when it can't reconstruct it, it shoots an anomalous score. But how can we tell it, hey, if there's a small change, don't worry, don't freak out, don't give us a lot of false positives. How can we retrain autoencoders so that it learns efficiently the changes in our organization? So that's an open problem that we're tackling. And you could probably think of another bunch of problems that you have at your organization that you could solve maybe with NVIDIA Morpheus. So one thing I wanted to mention before I leave you all alone is that I got permission from Google to start this organization kind of club thing in our campus called Build with AI. So what Google has let me do is they have these things called Google developer groups. So there's just groups of developers that come together on campus. In my case, since I'm organizing it and I'm a student, they were like, you have to do it on campus. You can't do it in a club outside. I was like, okay, fine, that's cool. So these are people on campus that come together, they code together, and we're gonna have this event. It's kind of like the trial event. So depending on how much traction we get, how many people we get come to our events, they might give us a go to establish an official chapter on campus. So if y'all are interested, it'll be open to the public, not just students. So you guys are free to come and help us boost our metrics so we can get Google on our side. And if Google ends up coming and letting us know, then I'll keep you updated. But we're gonna have a workshop hopefully this summer, maybe around June 15th, I think, or like July 15th, something around that. And we're gonna do a cool workshop with AI. So you guys are invited to come, and that concludes my presentation. Thank you guys. Are there any questions before I pass it over?
Yeah. So I just, I'm fairly illiterate when it comes to AI. So if I say anything that I'm factually incorrect, feel free to be like, well, let's take a step back. So from what I understand, to kind of get the determination that you want from AI, you need to build that context. So you need to have some file that says, hey, you are a security engineer, and this is how you approach these problems, and this is how you synthesize, like this is kind of the investigatory process that you go through. Does Morpheus also have some similar context building, rather, I'll even ask an open-ended question. How do you build that kind of structure or context with Morpheus? Do you do that with Morpheus? Because I know
it sounds like you're talking about like prompting, like giving an LLM instructions. So like where you mentioned you are a security analyst, you do this and this and this. That's like telling an agent, kind of giving it a prompt or an instruction to do something that it does it like over and over and over again. So NVIDIA Morpheus isn't an agent SDK like Google has or other people have, where you have an agent and you give it instructions and it does something. We're not building agents here. We're building, I guess, systems for getting data and putting it through a model. And I guess the model itself isn't an agent. It's an inference model where you give it data and it comes out with a determination. It doesn't do anything. Like it doesn't do any action like write me a report about this and this. Like you don't give the model a set of instructions like you are a security analyst, you do this and this and this. The whole point of the model is that we train it to learn something. And if we give it data that's never seen before, it should come out with a determination that fits what we've trained it on. If that makes sense.
Again, correct me if I'm wrong, or if I'm oversimplifying it, but it's essentially like a chat GPT for your data, where you're able to ask a question and it, based on the information that it has, it'll come up with some response.
Right. Where the question is data, right? The question is data that comes in, and the response is like I guess some alert or some thing on your dashboard that pops up. That would be the response.
Okay.
It's not like a text response where it gives you like a set of text that comes out and it's like, hey, this is what's anomalous.
So so the workflow that you used, because I'm trying to picture it in my head, was some platform where you set up the ingests, wherever the data is living, you set it up so that it can feed into the model. And then in this Morpheus platform, you're able to set up whatever dashboards, for example, you want. Is that what it looks like in real time, or does it look something different?
So I'll start with the dashboard part. The dashboard isn't part of Morpheus itself. You have to set up the dashboard and kind of just link it to
Kibana.
Right, exactly.
Okay.
Right. So it works with Elasticsearch or Kibana, but it doesn't come, like plugged in as part of it.
Oh, so you're setting up inputs and these, whatever ingests, and you're also setting up whatever outputs to go to whatever it is that you want. Incorrect?
Okay, well, let me go back to the kind of the framework slide. So
right,
you're setting up the pipeline that data goes through. I guess the data lifecycle. Anything that happens after, like Kibana or anything like that, that's not part of Morpheus.
Sure.
So the whole point of Morpheus is that it has some way to take care of your data, so that you can get, I guess, inference from it, or like predictions or determinations from your data. Right.
And now you can see those determinations and draw your own conclusions from them. Interesting. Cool.
Right.
Nice.
So I have a question then, just kind of building off of that. So really the models that are in Morpheus are more deterministic models, basically classification models that say this data is this or it's that. It doesn't really do reasoning or anything like that. It's more of a piece of data comes in, I classify it, push it through the pipeline.
Yes. When it comes to the autoencoders, we're not doing any classification there, because what the whole point of the autoencoder kind of solution is, the neural network, is that what it's telling us is that it couldn't do something. Like there's an error here. So it just tells us I couldn't recreate the input that I'm usually trained on, like the baseline. So it gives us an error. Like, oh, I couldn't recreate it. That's what it tells us. And then we can like take the conclusion like, oh, this is an anomalous behavior. Why? Because the neural network couldn't recreate it from what's usually happening.
Okay, so it's really kind of a 1 or 0 type thing, where the model just says, I could do what I could do before, or I couldn't do. Like this matches or this does not match.
Yes,
basically.
and usually, I mean, it's on a scale, right? It's like from like 0 to whatever it is.
Yeah.
So depending on, and we have the red line's a threshold. So in a security analyst kind of thing, you would have a threshold of, if it's above this value, then I'm gonna flag it as anomalous.
Yeah.
So we have a threshold here. Anything above the threshold gets alerted.
Okay. Interesting.
Mhm.
Any other questions?
So I don't know if you looked at this in your research or when you were experimenting with this. What does cost and usage look like? Like, how does this end up scaling out? Is it, do you know if it like charges per prediction, per like data ingest? What does that end up looking like?
Well, I guess it charges your electricity bill. Because think of
yeah,
it like
yeah.
the model is free, right? But you put the model on a server. The model is some sort of software that lives on a computer, and it uses your GPU power to come up to like power its neural network, its brain. So there's no like token usage where or like cost usage where you're paying somebody to give you to, because when with Claude or like GPT, you're paying someone to run inference on their servers.
Yes.
They're charging you for their electricity bill.
Yeah.
Right. In this case, you wouldn't be running it. I mean, there's a paid option, of course. Nvidia gives you the paid option. You could pay them to do inference for you. But this is the option where you run it on your own server.
Yeah.
Right?
Okay.
So, yeah. There's no like cost except electricity and power.
Got it. Yeah. I think I was bringing in my Claude, like, cost per prompt or whatever it is. Okay, cool.
But it's these models are a lot simpler, so the inference is a lot lower.
Yeah, it's a lot better. And then those Claude models, they're trained on the whole internet, right? The whole internet. So they're heavy, right? They're like billions of parameters big. These are only trained to do one thing.
Yeah.
Or multiple smaller things, like the anomaly detection, right? Or it trains on your data.
Yeah.
Specifically, only. Because you can't ask it, write me a Python script that does this, right? Because it's not like a chatbot. You can't type to it. You have to send it data, and it does inference on your data, and it comes back out.
Interesting.
How long did you train? Sorry. How long did you train your model?
It took like less than 5 seconds.
5 seconds. Wow.
Because so I'm using I think it's they have different on Google Colab. I think I have a Google Colab. Well, it's like a T4 GPU, I think, something like that. So Google Colab gives you like these. The Tesla T4. So these are like made for running inference on. So even though they have like not that much GPU, like as you would maybe in like your gaming PC, they're made to do computations. Like you can't use this to play games on it.
Right.
You use it only for computation. So they're optimized for running computations on your data. So they run pretty fast. I mean, and my neural network was, since it's for research, it's not that big.
Right.
It's not like a production neural network.
Enterprise.
Yeah, enterprise now.
Yeah,
It took very little time. In a real enterprise, your neural network might be a lot bigger. It probably will be a lot bigger. Because they're training on more data.
Yeah.
You want it to be more accurate. But for research and for playing at home, it takes like 5 seconds. Yeah, it's not that expensive.
Did it take long to kind of sink your teeth into it and kind of get the pipeline going, or was there a lot of hitting your head against the wall to, get everything linked up together and get the thing working the way you wanted it to?
I think it's pretty simple.
Yeah.
In our case, I used a database online. So I took someone's database. It's called the search database, I think. So it's like insider threat information. So they have like a bunch of logs, like simulated logs, and some of them are insider threats, I guess, like anomalies in the database. And you train your neural network on part of the database, and you give it the other part to kind of do inference on. So I guess it's not too crazy, since making the neural network itself isn't as hard as you might think it is. There's a lot of tools like PyTorch that make it super easy for you to do. So yeah, all I did was I got this database, I fed it to my model, I trained it, I gave it data it's never seen before to measure its performance, and then based on how it does, you can tune the model.
Interesting.
So
cool, very cool. Yeah.
So it's not too difficult to do, and everything's online. You could ask AI. AI is pretty good at it. I tried it, and it didn't do too many mistakes. So yeah, everything's open source too. So
Nice. Gents?
Thank you.
Thank you.